Okay, so don't have a lot of time. I was hoping to actually spend a little more time explaining some things, but it's lesson set 13, and these first 40, 50 problems have been on the first 10 lesson sets, I think, with probably explanation. So you can always go back and look at a similar problem if you don't understand where I'm getting my answers from. And then if you want in the comments, ask me to really talk about a particular numbered problem, explain how I got there, fine. But I only have time to mental math these critters. And if I go through it fast, it's because I've done so many of them. It's not because I got anything up here. All right. So it really comes from just hard work, persistence, and then I've had some insights because of the repetition that I've done that I think probably uh, probably uh, probably done as many quadratics as anybody out there. So let's just have at it. So the first one, I didn't even have time to put that down this time. 2, 3, 4, 5, 6. All right, so I'm going to put the answers here. And then, you can pause the video at any point and try the problems. I'm just going to put the answers in because I don't have any more time today. All right, so equation of a line through these points. Dropping in a 16, so 5/16 x. Writing that in, I guess, slope intercept form, so minus 2/5 x. I put that on the piece of paper as an answer. I got -8 plus 30, so that's plus 22 over 5. I'm looking at 3 points. I'm going to start with -4. I'll start with that column, and I'll change that column by 3. -1 and by 3, so I'm going up 3, so 2. And then I've got a 5, and I'm going to do what? I'm going to go up by 2. 7 and up by 2, 9. Plug 2, 9 in, make sure it works. So I'm looking at this and I'm adding 20 to that, which is 114. So I'm going to divide by 113 and I'm going to bring the 4 over. So that's 19. Number 5, I'm going to multiply by 10. So I've got -6, 15, bring the 6 over, 21. I'm going to divide by 21, 10, 20, 40. So -60. You can reduce that later. Number 5, perpendicular. Well, I know it's right there, it's staring me in the face. Oh, it's 17. So through ubiquitous esoteric, x minus u plus e, you drop the letter u in, you get e. Okay, I don't have Rene Descartes with me. He's over there. Sorry, Rene. All right, maybe you can come over on your own someday. All right, so what do we got here? I'm counting. I see 25. I see 4, so I see 21 times -3 is -63. That's right, I copied that right, so -63. Let me do that again. 25, 21, -63. Well, that's what's on the board. I'm not sure that's on the worksheet. X minus 5 times x minus 2 gets me the first 2 terms. And I know that if I want to cheat the system, I can drop a 5 in, and I got 35 minus 35, I got -11. Over x minus 5. All right, but I'm not explaining anything. All right, the inverse of this is x minus 3 over 7. All right, vertex 4, 7, so I write x minus 4 squared plus 7 squared change. Drop an 8, you get 16 units of change. You didn't want 16 units of change. 7 to 18, you wanted 11. 17, the inverse of this. Pretend you're solving an equation with x over here. First thing you're going to do is divide by 3. Next thing you're going to do is the inverse of 5 to the, which is log base 5. And the last thing you're going to do is add 2. Okay? So I need a cube root 8. I got to do it 4 times, and I got to flip it. So -4/3. All right, let's keep on going down the line here. All right, can we see everything? Yep. No, I'm back here. Don't fall off the table, computer. Stay right there. Don't move. Don't move. All right, I'm in the right place. Factoring. M minus 6 times m plus 5. Roots, measuring from 4. So x equals 4 plus minus. Got to go up 11 units and divide by 3. Square root. All right, 5x squared, 25x squared minus 2, minus 50x squared. Minus 3, minus 15, doubled, minus 30 times minus 2, 60x. 3 squared 9 minus 18, 10 minus 18 minus 8. 22. Find the x and y intercepts. Cover x up, you got your y-intercept, 0, negative 10. Cover the y's, you got 20/3. Connect those two places on the coordinate system, and you got the equation of a line. Equation of a line, 0, negative 10, 23, bump, you're done. All right, 2a squared plus a minus 15. Well, I know I got 2a times a. So writing it, I don't have to think about that right now. I want to get a, factors of 15 that get doubled. Well, 3 gets doubled, I get 6. And 3 goes with a 5. Okay, I can see I got a and I want it to be positive. So that's got to be positive, that's got to be negative. 24. Answers are right there. X equals 0. You make this one 0, you get a 0 out. You make that one 0, minus 3/5. That dimension's gone. Whatever x to the 2, 3, 4, 7th. This is an x to the 7th. So there's imaginary stuff going on here too. But we're not going to deal with that. Just real roots right now. Last one, 33/2. All right, next problem. I got to move a chair. Renee, you let me down. Remind me that I need you next time. All right. Where am I going? Oh, here. Yep, you can see that. It's finding a maximum. All right, so I know that I'm going to do minus b, minus 12 divided by minus 3 is positive 2. So 24 cut in half is 12 minus 1. The maximum is 11. All right, I'm going to look for plugging in 0. I believe I said find the y-intercept. So if you plug in a 0, we're looking at 1/3. What do you put on top of a 3 to get a 1/3? Negative 1, negative 2, plus 5, 3. F of x and g of x, and I'm doing, there was another problem on the sheet, I thought. I think it was f of g of something. I don't have the sheet. Do I have the sheet? F of x, what number am I on? Okay, I'm on page 2. That's too bad. I'm on page 1 here. Page 2. Well, let's just make up a problem here. New problem. So it was f of g of, let's do something like 3. All right, so if we put 3 in to the g function, we get 4. We put 4 in here, we get 2, we get 9. And that was problem number, who knows what, 27. All right, so the inverse of f of x, get my eraser. The inverse of f of x. All right, so if I'm going to solve this equation for x, the first thing I would do is undo exponentiation, which is log base 1/3 of x minus 2. Oh, I'm doing the inverse. Okay, I had a glitch here now. So let's solve this equation for, just to get my brain working again. So I would do that to that number and then add 2. Okay, so I want log base 1/3 of x, and then I'm adding 2. Now to check that, because it took me a moment, I'm going to plug a number in. I'll put 3 in. 3 gets me 3. 3 negative, I don't like that. Oh, it was base 3. Why did I say 1/3? Okay, yeah. So now 3 minus 2, 1, 3 to the 1, 3. Put a 3 in here, you get 1 plus 2 is 3. Okay, that's my answer. Log base 3, that's problem 28. Log base 3 of, where am I? Log base 3 of x plus 2. Okay, so let me step back. That got me all followed up because I think I gave a composite. All right, y equals 5. So y equals 5. How do I get from 5 to 8? Up 3. Next time I don't go up 3. I have a different differential. 5 to 11 is 6. So this is the base 2 exponential function. And then we do with the equation of a line. We make a 0 out of 1903. And then we ask ourselves, how long did it take for this doubling to happen? This doubling of the differentials. 1923 is 20 years. Okay. Logarithmic. Well, we always start with y equals. Problem 30. I don't know what my problem is over here. So problem 30, we start with, where can I write this? I'll write it here. So I'm looking for a y value. I got one, 1947. How do I get to 1950? I add 3. It's a logarithm. How do I show the asymptote? X equals 7 by the statement x minus 7. Numbers have to be bigger than 7 or this calculation doesn't work. How do I get from 7 to 15? Change of 8. And what happens when I put a 23 in? I get 16 over 8, which is a base 2 log, and we can see the 8 and the 16 right there. I think, I hope, I didn't look. All right, next problem. I think I'm gonna get this done in time. All right, so I can see that's a 4. I want a 0, so what am I gonna do? I'm gonna bring the 3 over. I'm gonna divide by -2, so I know I have plus minus the square root of 3/2, it's imaginary. And I'm gonna bring the 5 over, so it's -5. That'll get you the roots in this quadratic. 81 minus 4, square root of 77. That's the missing number. I think I wanted the sign of that too. So we have now a triangle where we have the square root of 77. We have x equals 2. The hypotenuse is 9. There's my angle. So the sine of that angle is square root of 77 over 9. Might as well get the cosine of that angle. We're just starting to move into trig. 2 to 9. Got to memorize your ratios. And the tangent, root 77 over 2. I don't think I asked for that, but I might have asked for that on the sheet. We're doing the first half of that sheet today. All right, so b equals 9 over here. So that missing number was square root of 77. What did I ask here? What would I have asked? -352. Oh, distance formula. Yeah, if you know how to do the Pythagorean relationship we just did, how far is it from -3 to 1? 4 units. 4 units squared 16. How far is it from 5 to 4? 1. So the distance between these 2 points is the square root of 17. Okay, pretty sure that's what I would have asked. I know if I bring that over and set it to 0, I've got factors of 1 and 3. So let's throw a 3 in here. 9 minus 3 is 6. So 3 is one of your answers. -1's the other. All right, so this is new for you. You haven't looked at that at all. But it's very similar to the problem we did over there. 2x plus 3y equals a constant. I don't remember what the constant was, but maybe it was. Maybe Freud's helping me out here. But plug in a 0, and you can figure things out. So make zeros. The whole course is based on zeros. So what are the 4 coordinates that I can see here? I can see if I put a 3 in, then what squared is 1? What squared is 1? 1 and -1. I can see if I put a 0 in here, I got to get a 5 in the numerator. 5 squared is 25. What makes y minus 3 5 or -5? 8 and -2. So 8 and -2, provided I make that 0. And if you look at that, if you plot it, 1, 3 might be there, -1, 3 might be over here, 0, 8. But did I botch this sucker? Let's see. Excuse my French. 1, 3, -1, 3. So 3, yes, that's right. So 1, 3, -1, 3. Oh, okay. I went 3 units there. So 1, 3, -1, 3, and then we have 0, 8, and 0, -2. I hope you start to see an ellipse. So we'll be doing those shortly. All right. One more batch of problems. Renee, come on, where are you? All right, I guess I got to try to show it here, but there's stuff in the way, and I don't want to lose my computer. Stay computer, don't fall. I think I can see everything. All right, so the last problems. Again, I apologize for the speed here, but nothing I can do today but to get it in front of you. And then you write to me about what you want me to talk about here. If there's 5 or 10 problems I can do when I do the second half of the sheet, I'm happy to do that. We're just trying to get the practice. So I start with 10 and -6. I can see that 2 is common, and I'm going to multiply by, oops. I usually put it out a little further. So I'm going to multiply by 5 and by -3. I see m and m to the 4th. So m is common, and I need 3 more over here. And then I got y to the 15th, y squared is common, right? And I have it over here, so that side's done, but I got to get from 2 to 15, so I need 13. You multiply that out, it's the same calculation as that. All right, so what did I have here? This is probably an exponential. I'm going to erase this because I need some space, I think, to do this. So y equals 5, this is an exponential. That's the asymptote. 11 is 6 units above 5. The next one is not 6 units above 5. From 5 to 27 is 22 units. You can reduce that later. X minus 1990. And how many years? Looks like 35. Okay. This one here was find the y-intercept. No, it was find the x-asymptote. I remember, I read it. Find the x-asymptote. Well, that's 9. Whatever makes a 0 is what gets you that part of a graph for a logarithmic function, making 0. When you do these problems, you really want to have log base 15 to the 0. That gets you your asymptote. The next thing you want is log base 15 to the 1. That gets you a 0. That's an easy number to work with. And log base 15 of 15 gets you 1. That's an easy number to work with. Okay, and that's how we're going to eventually graph those quickly and easily. All right. Just putting some things in your head. All right, let's do this together. I see 27. I'm going to move it to the, okay, let's just do it right here. Wow, no, I should put these answers over there. That's my mistake. All right, so I see a 27. I see I'm dividing by 2. I see I have log base. I have 1/3 to the, so I want log base 1/3 of that. Now I have x minus 4, so over here I have to add 4. Did I do that right? I don't like what I'm seeing. So 27 halves minus 8 halves is 15 halves. I don't like that. So let me do this here because I think I'm getting tired and making a mistake. So I got to bring 27 over. I got to divide by 2. Now I have 1/3 to the x minus 4. That is x minus 4 equals log base 1/3 of 27 over 2. Yeah, I think that's correct, but it looks odd. I cannot see this minus 4. Well, anyway, I'm going to move on. Yasser, come to the plate. You're a designated hitter right now. I'm going out of the game. You come in. You do that problem for us, and let me know if I made a mistake. All right. He's my assistant now. We might even get over to Darn. I think your neck of the woods. My wife wants to get over there. Who knows? I'll even see you someday. Roots. All right. So I want the vertex. So I'm solving this for 0. So I'm gonna attack the vertex right here. Because then I got the roots. So minus b, 4 divided by 4 is 1. Well, that's not a problem. So x equals 1 plus minus. I got that. Drop a 1 in, -4, -2 plus 19 is 17. So I got 17. I got my a value, and I got my roots. Should be that. And imaginary, I think. Right? Should be imaginary. Because that 17 is going to the other side. All right, I didn't botch it. I almost did. So here I am. 1 plus or minus the square root of 17 over 2 imaginary. All right, 42. I see what's common is x to the 4th. So I'm only going for real roots. So one of them is x equals 0. All right, if x equals 4th equals 0, then they're both 0. And that means that if I take 4 out, there's 1 left. That's over here. So 7 over 20. All right, so I got enough time to get upstairs to a department meeting. And then that's about all the time I had. So I'm sorry it was rushed like that, but at least you got an answer key. And this is all about you getting practice. So go get some practice. If you made mistakes, try to figure out where and why. But feel free to write saying, could you please do number such and such and take more time? And then I can tell you where there's a video where you can get 5 or 10 practices. But most of the things, I don't have anything organized. You know, when I started this, it was during COVID, and I wasn't intending to be on YouTube, but I got there, people started chiming in and whatnot. I said, well, I'll keep doing it. And now my goal is to keep building these worksheets up right through calculus, but I'll be doing it in a library or somewhere else because I'm retiring in a couple of months. So chime in if you want me to do a particular problem. As I say, somewhere in the YouTube channel in one of the playlists probably is a rapid fire 5 where you do 5 in a row. And I suggest you try to, you know, do 1 or 2 in a row and then see if you can get the 3rd, 4th, and 5th like that. All right. All right. So got to run. Bye-bye.